The Pendulum Simulation is an interactive educational tool designed to help students explore and understand the principles of pendulum motion. By providing a hands-on approach to investigating the factors that affect the period of a pendulum, the simulation offers a comprehensive learning experience that covers fundamental concepts in physics. The simulation allows students to play with one or two pendulums, adjust various parameters, and observe the effects on the pendulum's motion. Additionally, students can explore the energy in the system in real time, discover the conservation of mechanical energy, and measure the period, velocity, and acceleration throughout the pendulum's swing. A pendulum is a simple device consisting of a mass suspended from a pivot point, which oscillates back and forth under the influence of gravity. The pendulum simulation begins by introducing the concept of pendulum motion, explaining how the pendulum swings due to the interplay between gravitational and restoring forces. The simulation provides an interactive platform where students can actively engage with the concept of pendulum motion. By adjusting various parameters, such as length, mass, gravity, and angle, students can observe how these factors affect the period of the pendulum. This hands-on approach helps students gain a deeper understanding of the principles governing pendulum motion. The pendulum simulation allows students to investigate which variables affect the period of the pendulum. The period of a pendulum is the time it takes to complete one full swing. By adjusting the length of the pendulum, students can observe that a longer pendulum has a longer period, while a shorter pendulum has a shorter period. Students can also explore the effects of mass, gravity, and angle on the period. They can observe that the mass of the pendulum does not affect the period, while the strength of gravity does. Additionally, students can investigate how the initial angle of displacement affects the period. Although for small angles, the period is approximately constant. The simulation allows students to explore the energy in the system in real time. As the pendulum swings, its energy is continuously converted between potential energy and kinetic energy. At the highest point of the swing, the pendulum has maximum potential energy and minimum kinetic energy. At the lowest point, the pendulum has maximum kinetic energy and minimum potential energy. By observing the energy in the system, students can discover the conservation of mechanical energy. The total mechanical energy of the pendulum, which is the sum of its potential and kinetic energy, remains constant throughout the swing. This principle of energy conservation is a fundamental concept in physics and helps students understand the interplay between different forms of energy. The pendulum simulation allows students to measure the period of the pendulum precisely. By adjusting the parameters and observing the period, students can gain insights into the factors that affect the period and understand the relationship between these variables. The simulation also allows students to view the velocity and acceleration of the pendulum throughout its swing. By observing these quantities, students can understand the dynamics of pendulum motion. For example, they can see that the velocity of the pendulum is maximum at the lowest point of the swing and minimum at the highest point. Similarly, the acceleration of the pendulum is maximum at the highest point and minimum at the lowest point. The simulation further allows students to explore the motion of double pendulums, which consist of two pendulums connected in series. The motion of a double pendulum is more complex and chaotic compared to a simple pendulum. By adjusting the parameters of the double pendulum, such as the lengths and masses of the two pendulums, students can observe the intricate and sometimes unpredictable motion of the system. Students can compare the motion of simple and double pendulums to understand the differences in their behavior. While a simple pendulum exhibits regular and predictable motion, a double pendulum can exhibit chaotic and seemingly random motion. This comparison helps students appreciate the complexity of physical systems and the importance of understanding the underlying principles governing their motion. The simulation provides an interactive platform where students can actively engage with the concepts of pendulum motion. By adjusting various parameters and observing the results, students can gain a deeper understanding of the principles governing pendulum motion. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the pendulum's motion, energy, velocity, and acceleration in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation covers a wide range of topics related to pendulum motion, including the effects of length, mass, gravity, and angle on the period, the conservation of mechanical energy, and the dynamics of simple and double pendulums. This comprehensive approach helps students gain a holistic understanding of the principles of pendulum motion and their applications in various fields. The pendulum simulation is a valuable tool for teaching and learning about the principles of pendulum motion. By providing an interactive, visual, and comprehensive platform, it helps students understand the factors that affect the period of a pendulum, such as length, mass, gravity, and angle. The simulation allows students to explore the energy in the system in real time, discover the conservation of mechanical energy, and measure the period, velocity, and acceleration throughout the pendulum's swing. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of pendulum motion and its applications in various scientific and engineering fields.